Okay, so welcome back, and this is Professor Shashikant Pathak from National Institute of Education. And today I'm going to discuss about polynomial functions. So let's just get started with what is the definition of a function and how a function is defined. So, but before that, I must tell you that polynomials, they do fit the definition of function. Function is relation. So basically, function is a relation which basically for exactly one input it gives out one output. So basically you provide one input here and you get another output here. So basically for one input there is one output outside. But the interesting part is that function is a relation, but not so basically polynomials, they do fit the definition of function, but all the functions, they are not necessarily all the functions, they are not necessarily a polynomial. So you have to be very careful in understanding this part, that polynomials, they are functions, but all functions are not polynomials. So let's write down here the mathematical, uh, standard form of polynomial function defined here as, let's assume that f defines here a function of x which can be expanded in terms of an x to the power n plus an minus 1 x to the power n minus 1, and then we can keep on moving like that, and we come here a term a2x to the power 2 plus a1x to the power, basically this is power 1 here, so we normally do not write power 1, and then we have a final term which is a0 or a0. So n here is the whole number, so I can write here the whole number. This is the whole number, and an is here, an is the coefficient, or basically it is a non-zero number, so it is the value of an is never zero, and n is a whole number, so we can write an as a1, a2, a3, and similarly. So term x here is independent of an. So this is an important point here to understand, that all these x and to the power n minus 1 x squared, they are independent of a2, and the value of n is the degree of polynomial. So I'll talk about what is the degree of polynomial and how degree of polynomial that is used in defining those polynomial functions. So let's take an example here. Let's take an example, and maybe let's write down a function here fx, which is, let's say, minus 2x squared plus x 1 by 2 and minus 5. This is a polynomial function, and so we have to test actually whether or not this is a polynomial function. So if you remember, I explained earlier in one of my previous presentations that 1 by 2 is an under root, and which is coming here as an exponent, and because of that this is not a polynomial function, because 1 by 2 is not allowed. Let's take another example here. Let's say fx is equal to 5x squared plus 3x squared bracket, and then 1 by 2 here and minus 7. Now this is slightly different, because the first term here is allowed because we have 5 as a coefficient, constant 2 is also a whole number, and this is an exponent, so which is allowed. But then we have here under root. Let's try to solve this part here, so we can write this as we can write here as 5x squared plus 3x. Now x squared to the power under root 3 to the power under root will come over 3 to the power 1 by 2, and x squared over 1 by 2 will become cancel out. So 1 by 2 into 2 is basically 1, so x to the power 1 and then minus 7. But then you see this 3 to the power 1 by 2 is a constant, and this is a variable. So that means this looks like a good equation. So this one is a polynomial function. This is good. This is a polynomial. Now let's take another example here, and this will be, if I choose, let's say, -3, and this will be, let's say, 1/2 here, and then I have here x cubed minus, then -3 1/2 again here, and then I have x squared plus 7x. So I've got three terms here, but they are defined in a different way slightly. This is first term, this is second term, and this is third term. Now this one is because this one is a constant, so is allowed. Exponent is real, is allowed. Variable is there, is allowed. But this one here is a term which is having a value which is basically, actually it should have been like this here. So in that case this is not allowed. When it is not allowed, so this is not a polynomial. Not a polynomial. Let's take another example here, the final one, and this will be fx. Let's write down with a different color here. 7x to the power 3/2 whole as 3/2 plus 3x squared minus 9x plus 5. Now you can see here directly that if you open it up, this will give you 7 to the power 3/2, which is fine because this is a constant. But then x will be coming here with 3/2, which is again a problem because that is in under root, so that function is not a polynomial function. So thereafter we can do a quick quiz here to understand a little bit more questions. One is, let's say there are two functions fx and gx, and then we have a couple of operations here. Like the first operation I would like to do is an addition. So if we are adding, this is the new function which comes out of the addition is a polynomial, of course, because that's the basic property. Then I have fx multiplied by gx. The two functions are multiplied, that is again a polynomial. And if I have fx subtracted by gx, that means I am doing subtraction on polynomials, so that's again a polynomial. But then the last I have the two functions, they are divided, fx by gx. Now here is a division, and this is division of polynomials is always a condition that what is the outcome. So depending upon what type of polynomials we choose, we may or may not be a polynomial. So I'll take this example later on in my next video to make it clear that why the division of two polynomials may or may not be a polynomial. That's very interesting to understand. So that's for this presentation. That's all for this presentation, and do not forget to check out my third presentation, which will be polynomials part 3. Thank you.